All right. Here's our test review. I'll be going through this one question at a time, so feel free to fast forward to any part that you need to, or just watch the whole thing, whatever helps, All right, but starting with number 1, which graph below would match the situation described? Also, by the way, left the window open, so if you hear like things happening out there, that's just what's called the world. So yeah, just ignore all of that if you hear any background noises. Which graph below would match the situation described? A car traveling at 23 miles an hour accelerates to 45 miles an hour in 5 seconds. It maintains that speed for the next 5 seconds and then slows down to a stop the next 5 seconds. So it starts at 23 miles per hour, then accelerates to 45 in the first 5 seconds. It stays at 45 for 5 seconds, and then it goes to 0 in the next 5 seconds. So that's going to be graph C. Graph C, you can see that it starts at about 23, and it's accelerating up to 45, and it stays at 45 for 5 seconds, and then it goes from 45 down to 0 in those last 5 seconds. All right, determine the graph, whether the graph represents a function. The answer to this one is simply no. It does not represent a function because of the vertical line test, which means basically if you draw a vertical line anywhere on this graph and it hits the function in more than one place, then it fails a vertical line test. So you can do it there, you can do it anywhere on this graph. You can see that hits the graph more than once. It should be a straight line, obviously. My lines aren't very straight, but you get the idea. You hit the function more than once in a place. It can be anywhere, right? Doesn't have to be everywhere, it just has to be in one specific spot. If you can find any spot where a vertical line hits the graph twice, then it fails the vertical line test. So give the domain and range of the relation. Okay, so domain is x values again, and the range is y values. Now, this table is given to us already, so we know our domain is our x values, which are in numerical order, -3, 0, 3, and 10. And our range is our y values. In numerical order, it's -5, 0, 7, and 21. All right, it's pretty simple. Number 4, give the domain and range of the relation. Tell whether the relation is a function. Now, this is a little more of a challenge. It's not as easy as number 3, although it's asking for the same thing, right? Give the domain and range. But none of the points are given. All we see is the graph. So here's what I need you to remember, okay? So domain, see if I can lay this down a little better. Okay, so domain is span of x values. Okay, it's from left to right on our graph. Oops. From left to right on our graph. Whereas the range is span of y values. Oh man. Every time I get to the edge, my finger slips a little bit. Of y values. And this is from bottom to top. So what we're doing is when I look at a graph and I'm looking for its domain, I'm looking at the furthest left the graph goes and to the furthest right. So if I look at my function, which is again, it's like J-shaped curve, right? The farthest left it goes is over here, right? Right here is the furthest left it goes. And if I draw that barrier all the way down, because remember, this is in relation to x, right? The x-axis. In relation to x, that barrier is at just about -3. So that's as far left as our graph goes. And then I look at the furthest right. And the furthest right is this point down here. And as far right, again, in relation to the x-axis, this wall is at about 1. So our domain is -3 to +1 because our function, right, goes as far left and as -3 and as far right as +1. So we write it -3 to +1. Okay, so it's a wall left to right. How far left, how far right the graph goes. Now the range is very similar, but it's going to be for the y values. So the y values is, again, the respect to the y-axis. It's from the bottom to the top. So the lowest point our graph goes would be right here at the bottom of our j. And with respect to y, that is at -5. -5 is the lowest that this graph gets. The highest point is, of course, right up here. The highest point at that point as well is, with respect to the y-axis, remember, we're talking about the y-axis, how high it is, it's at 4. So our range is all the way from -5 up to +4. So our range, -5, oh, this is y values, not x, so all the way to +4. So it's create those barriers, create the wall that goes left and right, that the barrier, the graph hits on the left, the barrier graph sits on the right for the domain. And then you can do the same thing for the y-axis, how far down, how far up it goes. Create a floor and a ceiling for it. Have the graph sit on the floor, that's the lowest point, -5, and have it hit the ceiling at its highest point, +4. So remember, domain is with respect to the x-axis, range is with respect to the y-axis. All right, number 5. I go ahead and do it. Yeah, I don't want you guys to get confused if you try to scroll through the video. Number 5. Number 5 was a graphing one, but we don't really have a graph, but I will make the best that I can. A word of advice. Let me go back to purple. A word of advice is always, always, always make a table before drawing a graph. So in this case, our table, it gives us a domain. It gives us x values to use. So we are going to plug in these x values. We are going to plug in 2, 1, 0, -1, and -2, because that's what the problem wants us to do. It gives us a domain. It gives us those x values to plug in. Now, in addition to that, we have our function, but our function is not really set up properly. It's not set up where I can just plug a number in, right? What I'm looking for is something where it's y equals, and then the rest of the expression. I would like to have this y here be by itself. If it's not by itself, it's kind of useless. So I'm going to move this over to the side. We have -3x minus y equals -1. So I need to have the y by itself. Now, I'm going to do this 2 ways. One is the more clever approach, the one where it's kind of easier and faster to do, but only if you can recognize that. It's going to be, it's harder if you don't see it, right? So, and then I'll go back to, and I'll do the more typical standard approach that we usually do in class. But the more clever approach is recognizing that this y is kind of already by itself in the sense that it's just -1y. It's not like 2y or 3y or anything, right? So if you think about it, you can take this y and move it to the other side. And when you do that, it will become a positive y, because how do you move it? You'd have to add y to both sides, right? You have to cancel this out, and then you'd have a positive y over here, which is nice because then it's just a regular y. And then all you have to do is get rid of the -1. So if you move the -1 to the left side, then the y is by itself. So it's basically just kind of a reversal, or like a flip-flop of the -1 and the y, right? You can move the y over here, move the -1 over there, and the y will be positive and all by itself, and everything will be happy, All right, so that would look like this, that you would add y to both sides, and you'd have -3x equals -1 plus y, and then you can add the 1 just to move it over there, and you'd have -3x plus 1 equal to y. So it's just kind of switching the y and the -1. The y is by itself, and we have a function that's usable. That doesn't necessarily work every time. I just figured if you recognize at the beginning, it might help. The more typical approach, though, is we try to move the x term to the other side, right? Leaving the y completely alone, just try to move everything else. Move the 3x to the other side. This would leave us -y equals 3x minus 1. And then because it's a -1 times y, we can divide by -1. And leave us with a positive 1y equal to a -3x plus 1, which is the exact same equation I showed you a second ago, but just found out through a different approach. Now this function is going to be useful because it's going to help me y equals negative 3x plus 1. It's going to help me graph, right? So first and foremost, before I make a graph, let's finish my table. So let's plug these values in. So if I plug 2 in, I'll have negative 3 times 2 plus 1. This is going to be negative 6 plus 1, which equals negative 5. So negative 5 goes for 2. If I plug in 1, negative 3 times 1 plus 1, negative 3 times 1 is negative 3, and negative 3 plus 1 makes it negative 2. No, sorry. Yeah, negative 2. Okay. If I plug in 0, negative 3 times 0 plus 1, that's going to be 0 plus 1, which is the same as 1. And then if you plug in negative 1, it's negative 3 times negative 1 plus 1, which is positive 3 plus 1, which makes it 4. So be careful. Double negatives there make it positive. And negative 3 times negative 2 plus 1, that's going to be a positive 6 plus 1, which makes it 7. So again, I had my function, and all I did was plug in these x values into that function. So I got all those outputs, got all of these outputs, and now I'm ready to just graph these points. So I'm going to have to draw my own graph. Sorry, I'm using up so much space, but I'm just, just a space hoarder here. Okay, 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2. It doesn't have to go 7, just that's what fits here. Okay. So we had the point 2, negative 5. So 2, negative 5 would be right about there. We had 1, negative 2. 1, negative 2 would be about there. We had 0, 1. We had 1, 4. And we had 2, 7, which is going to be way up there. Or negative 2, negative 7. And there's our points. Now, remember, there is no line to connect these. No line. Just leave it as just those 5 points. Okay, the reason we're doing that is because our domain that was given was a discrete domain. It does not want a line. It only wants those discrete points, those 5 points. All right, number 6. Give the domain and range. All right, hold on 1 second. Okay, give our domain and range. So our domain, again, is our x values. So our x values here are, those, and I'm just going to list them again in order. So negative 10, 0, 5, and 9. And our ranges are y values, which again, I'm going to list in order. So negative 19, 0, 11, and 19. That's it. Number 7. For f of x equals negative 5x plus 4, what is the value of x for which f of x equals 29? So again, it's asking for the value of x. So we're not plugging this in for x. 29 is not x, okay? The 29 is what f of x equals, meaning essentially the y value equals 29, not the x value. So what you're going to do to solve this is actually plug the 29, right, in for f of x. So you're actually putting 29 in for f of x. 29 equals negative 5x plus 4. So you're not plugging it in for x, you're actually plugging it into f of x, or the y value. So your equation is 29 equals negative 5x plus 4. So we solve this for x because that's what we're asked to do, right? Find the value of x. So we're going to subtract 4. This leaves us 25 equal to negative 5x divided by negative 5, and we get negative 5 equal to x. So our answer is x equals negative 5. All right, number 8. Number 8 is very similar, except for it says find f of x when x equals 1. So in this case, x actually is negative 1, so we actually do plug that in to x. So f of negative 1, meaning plugging in negative 1, is negative 4 times negative 1 plus 2. So that is a positive 4 plus 2. Oops, almost wrote the answer there. Positive 4 plus 2, which is 6. So f of x, or f of negative 1, which is just f of x evaluated at negative 1, equals 6. All right, number 9. So use the graph of the function to determine the value of y when x is 2. So when x is 2, that's right here. Remember, our x-axis is 2, right? We have to go find the function when x is 2. So if we trace our way all the way up, right, we'll run into our function right there. And so our y value at that point is 6. So our answer is y equals 6. Or you can say f of 2 equals 6, right? The function evaluated at 2 is 6. You can also find this out by plugging in 2. That's a little harder. I mean, it's not that hard, but it's a little more work because you have the graph already, so you might as well just look at the graph. But yeah, if you plug it in, 2 times 2 plus 2 is 4. 4 plus 2, which makes 6. I can't erase it anymore, so I broke something. Okay, there we go. 4 plus 2, which still equals 6, right? Either way, you can plug it in or just use the graph. I would just use the graph. I think it's easier. Okay. So the function y equals 40x describes how far from home Shuling is as she drives from Dallas to Miami. Graph the function, use the graph to estimate how far from home Suling is in 12 hours. So again, before I graph something, what's the first thing I should do? Make a table, okay? So f of x equals 40x, I believe, right? Yeah, 40x, or y equals 40x, same thing. All right, so it does not give me any x values to plug in. It just says, here's your function, go ahead and graph it. So that means we have to pick our own x values. Now, because it's a word problem, there's no reason to use negative numbers here because x, remember, does it say? X refers to, it doesn't really say, but x refers to hours in this case. So what I would do is just use numbers that make sense, starting with 0. Now notice I have to go up to 12. So I could just do 0, 1, 2, 3, 4, and all the way up to 12. But just to make it a little easier, I'm just going to go by 2. So I'll do 0, 2, 4, 6, 8, 10, and 12. That way I don't have to do all of them, but I do have a handful, right? I do have plenty of points to plug in. So now we're just going to plug those values into the function to see what the y value is and then graph it from there. So we'll have 40 times 0, which is 0. 40 times 2, which is 80. 40 times 3, which is 100. Oh, wait, no, 40 times 4, sorry. 160. 40 times 6, which is 240. 40 times 8, which is 320. 40 times 10, which is 400. And lastly, 40 times 12, which is 480. So I have these points. I have my x values and I have my y values. So I'm ready to go ahead and just graph this. So I'm going to use the number line. I'm going to go from 0 to 12. So I'm going to just go 2, 4, 6, 8, 10, 12. And let's have this axis go by, we'll just go by 80. Why not? 80, 160, 240. And that's 0. 320, 400, and 480. All right, so 280, 4, 160, 0, 0, of course, gotta get that. 6, 240, 8, 320, 10, 400, 12, 480. And we do connect this with a line because it's the values were not given to us. We chose those numbers. Whenever you choose the numbers, that's when you draw the line because, you have to trace out all the points that you could have plugged in but decided not to. So it's all going to be on that line. And to answer the question at 12, it was 480, right? How far from home is she in 12 hours? Well, the answer would be 480 miles. All right, number 11. For f of x equals negative 5x minus 2, evaluate f of 5. So what this is saying is x equal to 5, right? So it means we're plugging in 5 for x. So f of 5 is equal to negative 5 times 5 minus 2, which is negative 25 minus 2, which ultimately is negative 27. All right. Brian has 64 flowers for a big party decoration. In addition, he is planning to buy some flower arrangements that have 18 flowers each. All of the arrangements cost the same. Brian is not sure yet about the number of flower arrangements he wants to buy, but he has enough money to buy up to 5 of them. Write a function to describe how many flowers Brian can buy Let x represent the number of flower arrangements Brian buys, and find a reasonable domain and range for the function. So our function is going to start with f of x equals. Now keep in mind, this is about flower arrangements. This is about how many flowers Brian has. He already has 64, right? And he can buy more in packs of 18, essentially, in bundles of 18. So for each bundle he buys, he gets 18 flowers. So 18 times x being the number of bundles of flowers that he buys. So there's our function, right? Starting with 64, buys 18 per bundle. Now, so that's the function. Now about the domain and range. Domain is reasonable numbers that we can plug in for x. Remember, x is kind of the bundles he can buy. It says in the problem that he can buy up to 5 of them, up to 5 bundles. So our domain would be 0, 1, 2, 3, 4, and 5, because he can buy up to 5. So we stop at 5 because he can't buy any more than that. Now our range is the outcome, or how many flowers he ends up having if he buys 0 or 1 or 2 or however many bundles he buys. If he buys 0 bundles more, right, then he has 64 flowers, because that's what he started the problem with. If he buys 1 bundle more, then he has 18 more flowers, which means he would have 82 flowers. If he buys another bundle, it'll be 100 flowers. So that's 0 bundles, 1 bundle, 2 bundles. If he buys a third bundle, it'll be 118. If he buys a fourth bundle, it'll be 136. And if he buys the fifth bundle, it would be 154. So, excuse me, our range is 64, 82, 100, 118, 136, and 154. I just put the 0, 1, 2, 3, 4, 5 underneath them just to kind of keep count. But the range is those numbers: 64, 82, 100, 118, 136, and 154. All right. Number 13, graph the function given with the given domain, classify the function as discrete or continuous, then identify the range. All right, so we're asked to graph our function, which is, I'm going to put over here, so we have y equals negative 1/2 x plus 6. All right, let's make a table. So x and y. Now it gives us x values to plug in: negative 4, negative 2, 0, 2, and 4. So negative 4, negative 2, 0, 2, and 4. So when we plug them in, this will be negative 1/2 times negative 4 plus 6, which is, all right, let me actually lower these so I can show my work a little bit better. Negative 2, 0, 2, 4. There we go. All right, negative 1/2 times negative 4. So 2 goes into 4 2 times. And both numbers are negative, so negative makes it a positive. So ultimately, this is 2 plus 6, which makes a total 8 there. All right, now if you plug in negative 2, we have negative 1/2 times negative 2 plus 6. Again, 2 goes into 2 once, and since these are both negative numbers, negative times negative makes that a positive 1. 1 plus 6 is 7. Plug in 0. 1/2 times 0 is going to be 0, of course, plus 6 means 6. If you plug in 2, negative 1/2 times 2 plus 6. So 2 goes into 2 once, and it's times the negative 1. So it is just negative 1 plus 6, which makes 5. And then lastly, negative 1/2 times 4 plus 6. So 2 goes into 4 twice, and then it's times it by a negative, and so you have a negative 2 plus 6, which equals 4. So there's your x values. Here are your y values. Now we'll graph it. So our graph look like this. So actually, make it a little lower. 1, 2, 3, 4, 5, 6, 7, 8. All right. So negative 4, 8. So negative 4, positive 8 would be way over there. Negative 2, 7 would be right about here. 0, 6 would be right here. 2, 5 would be right here. And 4 would be about there. And again, our domain that was given to us is a discrete domain. So we do not draw a line, and our range is 8, 7, 6, 5, and 4. So our domain was those values, and our range was those values, 8, 7, 6, 5, 4. Or you can just say 4, 5, 6, 7, 8. All right. Does the input-output table represent a function? The answer to this one is yes. And I can tell because no duplicate x values. So remember, a function is a function if every x value goes to exactly one y value. So what I mean by no duplicate x values is, say for example, I had 3 here instead of 6. Then I would have duplicate x values. I would have a 3 here and a 3 here, 2 x values. And what that would indicate is that 3 goes to 14 and 3 goes to 29, meaning that the x value of 3 goes to 2 places, 14 and 29. So that's what you're looking for to identify something that's not a function. In this case, there's nothing like that because there's only one 3 goes to 14. There's only one 4 that goes to 19. There's only one 5. There's only one 6, right? They each have their own pair. So that's how I can tell it's a function. And the last one, the distance traveled in meters by the Oregon slide can be modeled by the function f of t equals 0.9t, where t is the time in minutes. Find the distance traveled in 27.5 minutes. So remember, t is minutes, and it's telling us 27.5 minutes. So guess what? That is t. So we're just going to plug that in for t. So 0.9 times 27.5. I don't have the calculator on me. I forget what the answer is. Let me check it real quick. 0.9 times 27.5 is 24.75. Let me double check that. 0.9 times 27.5 equals 24.75. Yep, 24.75 as an answer. That's it for the review. I hope it helps. Let me know if you guys have any other questions. Good luck on your tests. All right, see you later. Bye.